Hello everyone. So you are all aware of that I am making a series of videos on nucleophilic substitution reaction. In this context, I have already published a video on SN1 reaction. If you haven't watched the video, I give the link in description section. You can watch it whenever you find time. So in this video, I am going to discuss SN2 reaction. Shall we start? First, let me explain the term SN2. S stands for substitution, N stands for nucleophilic, and 2 stands for bimolecular. With this basic idea, let me explain this SN2 reaction with a general example. For that purpose, I have taken methyl halide here. And this methyl halide is treated with sodium hydroxide. We know that sodium hydroxide is getting ionized into Na plus and OH minus. So this OH minus is acting as a nucleophile. Once the nucleophile is attacking that methyl halide, it leads to the formation of methanol, and sodium halide is obtained as a byproduct. So this is a general SN2 reaction. Now let me explain this SN2 reaction with the detailed mechanism. For the purpose, I have taken the OH minus here. We know that the OH minus is acting as a nucleophile in the previous case. So this OH minus can be written as nucleophile. So this nucleophile trying to approach this carbon atom from the backside to the leaving group. That means if the leaving group is present at right hand side, means the nucleophile has to approach from the left hand side. Why it is happening? So you may ask a question, sir, why not this OH minus can approach from the same side to the leaving group? Means what I will explain here. So what happens here, this OH minus is trying to approach from the front side to the leaving group. Means what will happen? So this OH minus is carrying negative charge. That means it contains electron. And this X also is getting leaving as X minus. So this also is carrying electrons. So that means whenever these two negatively charged species, they are coming closer to each other, there will be electron repulsion will obtain. Okay, so in order to avoid this electron repulsion, always the nucleophile will try to approach opposite to the leaving group. Suppose if the leaving group is present at right hand side, means the nucleophile will approach from the left hand side. Suppose if the leaving group is present at left hand side, means the nucleophile will try to approach from the right hand side. So that means always opposite to the leaving group, the nucleophile attack will take place. Fine. So I am just removing this front side attack part. Right. So once the nucleophile is approaching from the backside to the leaving group, and there will be a formation of a penta-coordinated transition state. If you happen to look at the transition state here, you can check here this carbon atom is connected to 5 atoms. So it is known as penta-coordinated transition state. Right. So once this transition state is formed, it means this OH is coming closer to this carbon and this X is leaving from the carbon. And this leads to the formation of the alcohol product, and this X is leaving as X minus. So this X is known as leaving group, otherwise called as nucleofuge. Right. So this is about the mechanism of SN2 reaction. So if you happen to look at the rate of the reaction, so in this first step, that is a slow step, that is formation of penta-coordinated transition state, is a slow step. And the second step, that is the formation of product, is fast step. So I have already discussed in SN1 reaction, that is always a slow step is a rate determining step. And if you happen to check the rate determining step, that is this rate determining step contains nucleophile as well as the alkyl halide. So with this basic idea, let me give the rate of SN2 reaction. That is, the rate is directly proportional to the concentration of alkyl halide and the concentration of nucleophile. In other words, the SN2 reaction rate depends on the substrate as well as nucleophile concentration. If you happen to look at the rate law, there are two molecules are involving, that is alkyl halide as well as nucleophile. That is why we are calling this SN2 reaction as bimolecular reaction. There are two molecules involving in rate of the reaction. So this is about rate of SN2 reaction. Now let us discuss what is the effect of substrate in SN2 reaction. For that purpose, I have given 4 molecules. The first molecule is tertiary butyl halide. Second molecule is isopropyl chloride. And third molecule is ethyl chloride. Fourth molecule is methyl chloride. Right. So that this tertiary butyl chloride is an example of tertiary alkyl halide. This isopropyl chloride is an example of secondary alkyl halide. This ethyl chloride is an example of primary alkyl halide, and this methyl chloride is an example of methyl halide. So we need to find out which is more reactive, which is less reactive in SN2 reaction, right? For the purpose, immediately you need to look at the rate determining step. So what is the rate determining step in SN2 reaction? That is the formation of penta-coordinated transition state is a rate determining step. So for the purpose, you need to draw the transition state of all the 4 reactants here. So in the first case, this transition state will be formed. In the second case, this transition state will be formed. Whereas in the primary case, this transition state will be formed. Whereas in the methyl halide case, this transition state will be formed. And you need to identify the stability of all the 4 transition states. In the case of first transition state, this molecule contains 3 bulky groups. Methyl groups are quite larger group. There are 3 bulky groups are present in the transition state. Already the transition state is less stable, and to that 3 bulky groups are present, which leads to the formation of steric repulsion between 3 methyl groups, and this transition state is less stable. Whereas in the second case, that is in the secondary case, you have 2 bulky groups, quite more stable this transition state because less repulsion will be there. Whereas in the case of primary alkyl halide, you have only 1 bulky group. So even more stable, this transition state even more stable. Whereas in the methyl halide, you have smaller hydrogen atoms. So in this case, the repulsion between the atoms will be minimum, and this transition state is most stable. So if you happen to look at the rate determining step, that is a formation of transition state. If the transition state is forming, that means it has to be stable. Then only it will form. If it is formed, means the second step will be already faster. So in this case, all the 4 case transition state, if you happen to look at the 4th transition state, that is a methyl halide transition state, will be more stable. That means this transition state will be formed very easily, and this will give the product very easily. So among the 4 alkyl halide, the most reactive will be methyl chloride, and next followed by you have primary alkyl chloride, and second one secondary alkyl chloride, and finally you have tertiary alkyl chloride. The tertiary alkyl chloride indicates the formation of this transition state, and this transition state already having steric hindrance, so this will not form that easily. Once this is not forming, means the second step also will not form. So among the 4 alkyl halide, methyl halide is most reactive, and the tertiary alkyl halide will be the least reactive. So this can be given in a statement, that is, when the bulkiness of substituent increases, SN2 reactivity decreases. That means when you are adding bulky group in a molecule, SN2 reaction will be already decreasing. Reason is, when the bulkiness increases, means there will be repulsion in the transition state, and as a result the SN2 reactivity will be decreasing. So this is about the reactivity of substrates. Now let us discuss the effect of solvent in SN2 reaction. So polar aprotic solvents are always suitable in the case of SN2 reaction. For example, we have acetone and DMF. What do you mean by DMF? That is NN dimethyl formamide. So acetone, DMF can be suitable solvent in SN2 reaction. So for the purpose, I have given a general reaction here. So when this alkyl bromide is treated with sodium iodide and acetone as a solvent, so this is getting converted into alkyl iodide. Right. So whenever you have sodium iodide and acetone, means then the reaction will be always SN2 mechanism only. Right. So I am going to explain what is the role of solvent in SN2 reaction. So for the purpose, I have given that molecules here. So we know that the sodium iodide is ionic in nature. So this Na plus and I minus will be present very closer to each other. So we need to separate this iodide from sodium ion. So for the purpose, we are using this polar aprotic solvent. What will happen here? In this case, the lone pair of electron on oxygen atom is making a complex with sodium. So that means this iodide will be free. So the nucleophile is now free. So this can easily react with this alkyl halide, and it will lead to the formation of the product. So that means the purpose of using polar aprotic solvent in SN2 reaction is So that you need to separate the anion from the cation. So for that purpose we are using. So this is about the effect of solvent. Finally we have the stereochemistry part. So for the purpose I have given a molecule here. So let us understand the configuration here. So the first priority goes to bromine, second priority goes to methyl group, third priority goes to deuterium, and fourth priority goes to hydrogen. Upon 1, 2, 3 is arranged in anti-clockwise direction. That means the configuration is S. So this S configuration molecule is treated with sodium iodide acetone. We know that sodium iodide acetone means the reaction is SN2 mechanism only. Right. So now this iodide is a nucleophile in this case. I have already explained that the nucleophile will be always attacking opposite to the leaving group. So we know that the leaving group is present right hand side. Right. So the nucleophile has to approach from the left hand side. Right. So this iodide is trying and attacking here from the left side of the molecule. And as a result, this Br minus will be leaving. And which leads to the formation of this product. Right. So if you happen to look at the configuration of the product, so the first priority goes to iodine, second priority goes to methyl, third priority goes to deuterium, and fourth priority goes to hydrogen. That means 1, 2, 3 is arranged in clockwise direction. The configuration is R. So that means the reactant configuration is and product configuration is R. That means you are getting opposite configuration product. So this is otherwise known as inversion of configuration. So the conclusion is in SN2 reaction 100% inversion product will be obtained. So this SN2 reaction is an example of stereospecific reaction. What do you mean by stereospecific reaction? Whenever a reaction is taking place at a chiral center and you are going to get only one isomer, that means that reaction is otherwise known as stereospecific reaction. Whereas you are getting a mixture of product means that reaction is known as stereoselective reaction. So in this case, the SN2 reaction is an example of stereospecific reaction. So with this, that SN2 reaction is over. So guys, whatever the things that I have discussed about SN2 reaction is very much useful to you. If you find so, you can like the video, share your opinion in the comment section, and do not forget to subscribe our channel. And I will meet you all in the next video, that is on SNI reaction. Until then, take care. Bye.